Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over part 2 of our next generation Accuplacer Arithmetic practice test questions. In this clip, we're going to be considering problems 6 to 10. Let's take a look at question 6. It reads, what number in the list above has the greatest value? So we have 8 thirds, 2.28, 10 over 12, and 0.199. So which of them in the list has the greatest value? So let's consider a tip real quick that you want to keep in mind concerning comparing fractions and decimals. Okay, so let's write this down. So a tip to keep in mind is that when comparing fractions and decimals, when I mean comparing, I'm talking about ordering them from least to greatest, or finding which is the smallest or which is the greatest. So that's what I mean by comparison. So whenever you're carrying that type of comparison, you want to express everything as decimals. Okay? Express all the numbers as decimals. That's the easiest way to compare a combination of fractions as and decimals as we have in this problem. Okay? Alright, so let's go ahead and start with the first one. The first one is 8 thirds. So is that the biggest one? Let's convert it to decimals first, since it's a fraction. Okay? Now how do we convert fractions into decimals? We simply use long division, right? Okay, so let's put up our long division bar. Now let's consider this as the doghouse, okay? So which of them, the numerator or the denominator, goes into the doghouse? So we want to remember that the top dog goes in the doghouse, okay? So the numerator is what goes into the division bar. So the top dog is 8, so 8 goes into the doghouse, and then the 3 stays outside. Now we have it correctly set up, so we can now carry out our long division algorithm. Now let's go ahead and divide. 3 goes into 8 how many times? 3 goes into 8 2 times. 2 times 3 is 6. When we subtract, you get 2. How many times does 3 go into 2? 2 is smaller than 3, so 3 can't go into 2. We have to insert a 0 here, so in order to do that, we have to add a decimal point, and then place a 0 here. 3 goes into 20 how many times? 6 times. 6 times 3 is 18. Subtract 2. So this pattern basically continues forever. So we have 2.66 repeating. That's the decimal form of 8 over 3. Now let's shift gears and take a look at the next number, 2.28. This is already in decimal form. For option B, since it's already in decimal form, we can easily compare it with option A. And what do you notice? You notice that option A is greater because in the tens place, 6 is greater than 2. Okay, so we can eliminate option B because option A is still the leader. Okay, now let's take a look at the next one, 10 over 12. This number is a fraction, so we want to convert it to decimals, okay? But if you just take a look at this number for a second, option C, which is 10 over 8, what do you notice? You notice that the numerator is smaller than the denominator. So that means the decimal form will be less than 1. And option A is greater than 1. It's 2.26. So we can see by comparison that option A should be greater than option C. Now let's assume that we did not make that observation. So let's go ahead and carry out the conversion. Okay. So we want to divide. The top dog 10 goes in the doghouse. And then we have a 12 out here. How many times does 12 go into 10? 10 is smaller than 12, so 12 can't go into a number that's smaller than it. So we have to put a 0 point and add a 0 behind the 10. How many times does 12 go into 100? 12 goes into 100 if you do your multiplication tables 8 times. 8 times 12 is 96. Subtract, you have 4. And now we can clearly see that in the ones place, option A has a bigger value. So option C is smaller than option A, and we eliminate that. Okay. Lastly, we have option D. Option D is already in decimal form, which is easy and good for us, 0.199. In the ones place, we have a 0 for D and 2 in the ones place for A. Option A is greater. Okay, so the greatest number is option A, 8/3. So let me just put them in order for you. So we had 8/3 is 2.66, 2.66 repeating, 2.28, 0.8, and that goes on. And then we also have 0.199. So if we order them from least to greatest, what do we have? We have the smallest one is 0.199, because compared to 0.8, it has a smaller number in the 10th place. What's next? 0.8, because the other numbers have 2's in the ones place, and this has a 0, and 2's are greater than 0. And then these two are smaller than 2.28, because in the 10th place, 2.28 has a 2, and 2.66 repeating has a 6. So 2.28 is smaller. And we have the biggest number, 2.66 repeating, which is basically 8/3. So this number right here is the greatest. Okay, this is the greatest. A lot of times they might ask you to order numbers from least to greatest, so that's why I just added this component to it. The answer to question number 6 is option letter A. Now let's take a look at question number 7. It reads, if Manuel deposits 25% of $130 into a savings account, what is the amount of the deposit? Okay, let's go ahead and write down the formula that's going to guide our problem solving process. Okay, so the formula that we are going to be using is the percentage formula. Now, what is the percentage formula? The percentage formula is as follows. Percent is equal to part divided by whole. This gives you the percentage in decimal form. Then when you multiply it by 100, you have the percent. Okay? Now, in this problem, we are given the percent and the whole. We're asked to find the part. Okay, so how do we do that? Now, we can substitute our knowns and unknowns into this formula and solve for part, or we can manipulate this formula to be in terms of part, and then we will solve that. Okay, so let's express this formula in terms of part explicitly. To get part by itself, how do we get rid of 100 and a whole? You can simply multiply by the reciprocal of that, which is a whole divided by 100. Okay, so this is one variation of the percent formula. The other variation that you need to know is coming up. It occurs because of the following manipulation. Okay, so if I multiply by whole divided by 100 on both sides, I am going to end up with this new formula. Part is equal to percent divided by 100 times a whole. Okay, remember we have our collection of formulas on mathgotserved.com under Accuplacer page in the test prep section, and this is one of the formulas that you need to know to carry out your computations of percentage problems. Okay, so you need to remember that percent is equal to part over whole times 100, and part is percent over 100 times a whole. Okay, now let's go ahead and solve the problem. We have the part, which is what we're looking for. The part of the amount he deposited is equal to the percent he deposited, which is 25%. 25, we'll divide that by 100 times the whole amount, which is 130. Okay, so let's go ahead and multiply this fraction, but we can reduce first. 25 goes into itself once and goes into 100 4 times. If you multiply across, what do you get? How do you multiply fractions? One way to avoid making mistakes is by expressing your factors as fractions. Okay? Now when we multiply these two fractions, what we will do is multiply numerator by numerator and denominator by denominator. Okay? That's how you multiply fractions. So you have 130 as a result of multiplying 1 times 130, and then 4 times 1 is 4. Now let's go ahead and divide this. We're going to use our long division again. I want to convert this fractional dollar amount into decimal form so I can compare it with the options that we have here. Alright, now top dog is 130. That goes in the doghouse. Put the 4 outside. 4 goes into 13. How many times? 4 goes into 13 3 times. 3 times 4 is 12. Subtract. You have a 1. You bring down the 0. 4 goes into 10. How many times? Twice. 2 times 4 is 8. Subtract 2. 4 goes into 2. It doesn't go into 2 because 2 is smaller. Put the decimal point and a 0. 4 goes into 25 times. Okay, 50. 5 times 4 is 20. The answer to question number 7 is option letter C. Alright, let's take a look at question number 8. It reads, what is 1582 plus 761? Okay, so this is just addition of digits. So one thing you want to remember is that, so let's recall, when adding digits, okay, you want to orient your digits by place value. Okay, so we can say you want to align digits vertically by identical place values when adding or subtracting digits. Okay, subtracting numbers. So that's something to keep in mind. If you don't align the numbers correctly, you will end up with an incorrect answer. So what am I talking about here? Let's take a look at this. We have the bigger one on top, 1,582. Now 761, 7 is in the hundreds place, 6 is in the tens place, 1 is in the ones place. So if you configure it like this, you are guaranteed to add correctly. Okay, so that's extremely important that the digits are properly aligned by their identical place values. Okay, let's go ahead and add. 2 plus 1 is 3. 8 plus 6 is 14. 4, you carry 1 over. 6 plus 7 is 13. Carry another 1 over. And then 1 plus 2 is 3. So 2,343. Sorry, 2,343. Correct answer is option letter D. Alright, let's take a look at question number 9. It reads, Xiaoming is making cookies. Each batch of cookies uses 3 eggs. If Xiaoming has 20 eggs, and assuming he has enough of the other ingredients to make the cookies, what is the greatest number of batches that he can make? Alright, let's take a look at the formula that will guide the problem solving process, okay? So the formula is as follows. This is a formula that you might have seen before in the previous installment of this review series. Total amount is equal to the product of number per unit multiplied by the number of units. Okay, so this is a formula that we talked about using to calculate total amount if you're given the number per unit and the number of units. Okay, now in this particular problem, we're looking for the number of number of batches that can be made. It says what is the greatest number of batches that can be made. In this particular case, 1 unit is 1 batch. So if we're looking for a number of units, what we need to do is express this formula in terms of number of units. So how do we get number of units by itself? If we manipulate this equation, this formula here, we're going to end up with another formula that you need to know to help you out in the Accuplacer Arithmetic exam. So we're going to divide both sides by number per unit. If I divide both sides by number per unit, I'm going to end up with another formula that you need to know. Okay, so number per unit. If I divide both sides by number per unit on the right side, the number per unit component cancels out. And we have this formula, which is the number of units. That's what you have left on the right side after cancellation. Number of units is equal to the total amount divided by what? Total amount divided by the number per unit. Isn't that nice? So this is another formula that you need to know. Okay, first one is total amount is number per unit times number of units. The next one is number of units is equal to total amount divided by number per unit. And there's still one more, which is number per unit is equal to total amount divided by number of units. Okay, all these formulas are available on our website underneath the Accuplacer Prep tutorials. Now let's go ahead and adapt this formula to this particular scenario that we're dealing with. As indicated earlier, 1 unit basically represents one batch of eggs. Okay? So if we adapt this formula, what we're looking at is the number of batches is the number of units is a number of batches equal total amount is the total amount of eggs, total number of eggs, and then the number per unit simply represents the number of eggs per batch. Okay, number of eggs per batch. We are given these two components and we are asked to find the number of batches. So if we substitute, we're going to have the total number of eggs is 20 and the number of eggs in each batch of cookies is 3. Okay? Now if you take a look at the options that we have, these are whole numbers, so we have to divide this out, express it as a fraction, and do the accurate method of rounding. Okay? If we want to express this as a decimal, we have the top dog is 20, goes in the doghouse, put a 3 out here. 3 goes into 20 6 times. 6 times 3 is 18. You have a 2. 3 doesn't go here, put a 0 and a decimal point. 6, 18. Basically, this pattern continues, 6.6 repeating. Okay, now when we are talking about numbers of batches of eggs, the number of batches of eggs that can be used doesn't make sense to have a fractional egg. For example, can you go to the store and buy half an egg? It doesn't make sense, right? So eggs come in wholes. So if we're thinking about the greatest number of eggs, of batches that can be used, we cannot consider this fractional component. In this particular case, we are going to round down. Okay, we're going to round down to find the maximum number of eggs of batches that can be used. So let's write down a short remark. Since we do not count fractional eggs, we round 6.6 repeating down to 6 Alright, so we have 6 batches of eggs. The answer to question number 9 is option letter B. Okay, let's take a look at question number 10, the last in this review series. It says, what is the value of 3.85 plus 0.004 plus 0.117? Okay, so one tip you want to keep in mind when adding decimals is very similar to what we talked about earlier. Let's go ahead and write this down. So tip for adding and also for subtracting decimals. Now what's the tip? This tip has to do with alignment. Okay, so when adding or subtracting decimals, what do you want to do? You want to align the decimal points vertically first. Okay? You align the decimal points vertically first, inserting the place value, the placeholder 0 where applicable. Okay, so sometimes you have to put in a 0 just to make sure that everything looks good, and then you go ahead and add or subtract. Okay, you normally append a 0 either to the far right or to the far left. Okay, you don't insert a 0 in between the digits. That's inaccurate. In this problem, we have 3.85 plus 0.004 plus 0.117. So we're going to orient these digits vertically first. Okay, so 3.85. So we're going to align all the decimal points underneath the decimal point of 3.85. So we have 0.004 and 0.117. We can put in a placeholder here so everything looks nice. We're now in a position to add. Okay, when you have your add-ins accurately configured, you can add with ease. Okay, so make sure you write properly and configure your digits nicely like this. Okay, 4 plus 7 is 11, 1, carry 1. 1 plus 5 is 6 plus 1, that's 7. In the 100th place, 8 plus 1 is 9. In the 10th place, 3 plus 0 plus 0 is just 3. Our answer is 3.971. The answer to question number 10 is option letter C. Thanks so much for taking the time to watch this presentation. If the contents of this tutorial were helpful in your preparation for the upcoming Accuplacer Next Generation exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just ask it in the comments section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to the remainder of this review series and other great math tools to help you master mathematics. And as indicated earlier, there are tons of tools at mathgotserved.com, including our formula sheet. Thanks again for watching and have a wonderful day. Goodbye.